Welcome to Study Loop.
Welcome to problem number 10.10. So this is chapter 10, dynamics of rotational motion. In this question we are given a rim of the solid uniform wheel. So this has a radius r. The horizontal force is F is applied. F is equals to 40 Newton. Radius is our 0.25 meter. The mass of the solid uniform wheel is 9.2 kg. So when the force is applied on this chord, so this is a chord, the force will act on the axle and it will start rotating. So the rotation start this way because the force is acting this way. So we have torque produced by this force on this rim or the wheel, which is equals to Rf sine theta. Theta is simply, we can take it like torque equals to Rf, simply taking the magnitude. Since both are acting perpendicular, so we don't need to care about the angle here. So torque equals to Rf, which is equals to 0.25 times 40. So the first part, A part, the question asks about the angular acceleration of the wheel and acceleration of the part of the code that has already been pulled off the wheel. So we need to find this A of the acceleration, which is related with the angular acceleration. So we have to find alpha and then A. I is our moment of inertia. So this is a uniform disk, which means that moment of inertia is half mr square. So we can use this formula, torque equals to I alpha. Alpha is our angular acceleration and A is equals to R alpha. A is our acceleration. So finding out alpha, we have alpha equals to torque over I. So torque over is our 0.25 times 40. So this is equals to 10 Newton meter. So this comes out to be, putting the value, half mr square. Mass is 9.2 kg, r is 0.25 meter. So putting these values, so this comes out to be 10 over half 9.2.25 whole square. This is equals to 34.8 radian per square. So this is our angular acceleration of the cord or the wheel. So the acceleration actually is towards the cord, which is A. So A is equals to R alpha, which is equals to 0.25 times 34.8 meter per second square. So this comes out to be 8.70 meter per second square. So alpha is faced by or affected by this wheel, but A on the chord is this vector, is this acceleration, which is a tangential acceleration. So this is tangential acceleration. Since the force is acting tangentially, so we have tangential acceleration on the chord. Now coming to the B part. So the B part asks the force that axle exert on the wheel. So the chord is exerting force this way. So to balance out, so the force acted on the wheel is this way. So we have minus F, or just say F, but in this direction. So we have B part now. The force that axle exert on the wheel is equals to minus F. Now the force is this way and we have mg force this way. So second force is equals to on wheel is equals to mg due to gravity. due to gravity. So total force is equals to F wheel gravity, which is downward. This is towards left. So this comes out to be F magnitude, total magnitude is equals to mg square plus minus F square. So F is our 40 Newton and m is 9.2 kg. G is our 9.8 meter per second square. So putting this value, we have under root of 40 square plus 9.2 times 9.8 whole square. So this comes out to be 98.6 Newton. Now we have to find this direction. So again, so direction should be in this way finally, because one force is towards left and the second force, which is gravitational force, so the resultant force should be in this direction. But we need to find out that angle between x-axis and y-axis. So this is equals to 10, let's say phi angle, which is force acting on y direction. Take the magnitude if you want to, force on x direction. So this is equals to mg over f, which is equals to 9.2 times 9.8 over 40, which is equals to phi, gives us 10 inverse of this value 9.2 times 9.8 over 40. You can use the calculator. So phi comes out to be 66.1 degree. So my force, let's make the x and y axis. This is x and y. So my angle is between fy and fx. So this is equals to this angle. And direction is in third quadrant. So we say that the angle between x and y axis is this much, or saying that the angle between force or x axis, third quadrant. So this gives us the whole direction of the force. So the force is acting in third quadrant, meaning that the force is acting this way and making phi angle with x axis between f and x axis. So now we are done with the part B, but the C part asks what if we change this f vector to this way. So again, so the axle feels this factor, which is minus f on the upward direction. So there is no effect on the angular acceleration because the f remains same. We have this factor, and again alpha is same and a is also same. But finally we have total force acting on the axle equals to mg minus f, which is equals to 9.2 times 9.8 minus 40, which is equals to 50.2 Newton. The mg is downward and this f is upward. So that's why we have minus sign here. So that's your answer for this question. You can take a look at the slides again. So this is our first slide, this is our second slide, and this is our third slide. Thank you for watching the video.